Before the first Soviet computer. According to Computer, A History of the Information Machine, the origins of computers lay in the making of numerical tables in the late 1700s. These tables were composed of such things as logarithms, trigonometry, as well as more specialized information for specific occupations. The calculation of these tables was done by people, usually teams of clergy or those with an affinity for numbers. Charles Babbage observed the weaknesses of the manual calculation of tables. He decided to use mechanical methods to eliminate errors and increase the speed of calculation. Although he was unable to complete an entire machine within his lifetime, he had completed a small prototype in 1833, which introduced the concept of mechanical computing. In the latter half of the 19th century, the United States was reaching limits in manual tabulation of its population. Herman Hollerith was able to capitalize on this opportunity, developing a system of punched cards and mechanisms to tabulate the results. With his tabulating machines, he enabled the U.S. 1890 census to be completed in record time. With his success, and the need to stay in business even when the census was not being tabulated, he incorporated his business as the Tabulating Machine Company and sought other applications for his machines. His tabulating machines found uses in many commercial and industrial contexts, while competitors drove his company to continue making improvements to the designs. In 1911, the Tabulating Machine Company was sold to a new holding company, the Computing Tabulating Recording Company. Thomas Watson, the general manager of CTR, changed the culture of the company in such a way that CTR's income more than tripled by 1920. In 1924, the company was renamed IBM. Meanwhile, there were developments in the area of analog computers. Vannevar Bush had an interest in analog computing since he was a student, when he invented a profile tracer. Later, he was to create a differential analyzer, which was used to solve a broad range of engineering problems and served as an inspiration to some. In 1936, Howard Aiken, a student at Harvard, was inspired to create a large-scale calculator. Inspired by a fragment of one of Babbage's machines and backed by IBM, he created the Harvard Mark I, which began operations in 1944. It was considered the first automatic computer. During the development of the ENIAC, John von Neumann was credited with creating the stored program concept. This enabled the future development of programming languages, reduction of needed components, and led directly to the EDVAC. The ENIAC was completed in 1945, after the end of World War II. Its distinguishing feature was that it was 1,000 times faster than the Harvard Mark I due to its non-mechanical architecture. During the next several years, a few more computers shaped the future of computing forever. The Manchester Baby Machine, completed in 1948, demonstrated that the stored program concept worked. The EDSAC, built in 1949, was considered the first practical stored program computer. The EDVAC was completed in 1949 and went into operation in 1951. Where were the Russian computers? Up to this point, there were no machines built in Russia which matched those of Charles Babbage or Herman Hollerith. One important reason for this absence was because Russia, in the early 19th century, had not experienced an industrial revolution. Babbage, in contrast, lived in the midst of the world's first industrial revolution in England. The resources which made Babbage's endeavors possible included machine tools, ready supplies of raw materials, and mechanical power. Another possible reason for the lack of a Russian Babbage or a Russian Hollerith might have been the prevalence of bureaucracy. In a story by Nikolai Gogol, The Nose, written around 1836, the ever-present and ubiquitous bureaucratic attitudes are portrayed in a light-hearted manner. On a more serious note, bureaucracy in Russia around 1916 was such that it was possible for factories to go out of business because they did not provide the proper stamp on their documents. It is very possible that the difficulties as a result of bureaucracy would have dissuaded anyone from creating machines as Babbage and Hollerith have done. Babbage had procured funding from the British government to pursue his goals, and the U.S. government was responsible for giving Hollerith his start with the 1890 census. Besides the bureaucratic conditions and the late industrial development in Russia, there was also the issue of internal strife. In 1891, Russia suffered from a major famine affecting 36 million people. The aforementioned bureaucracy rendered the government unable to adequately respond to the crisis, exacerbating the situation. In 1905, conditions had deteriorated to such a degree that workers pleaded to Tsar Nicholas II for help. Unfortunately, they were received with violence. There were yet more famines in 1906, 1911, and 1921. The rule of the last two Tsars, Alexander III and Nicholas II, were possibly yet another factor for why industrial calculating machines did not arise in Russia. They viewed modernity and ideas from the West as threats to their own power, and thus did not promote innovations and new ideas. After the removal of Tsar Nicholas II from power in 1917, the conditions were still not conducive to the creation of computers. Russia was involved in the First World War, withdrawing in the latter part of 1917. This led directly into the Russian Civil War, where the Bolsheviks eventually achieved victory in 1921 at a heavy cost in human lives and resources. The rapid industrialization that was instituted by Stalin's 5-year plans established a basis for the construction of computers. By 1935, the Soviet Union greatly increased its industrial capacity. A few years after the end of World War II, it was ready to create its first computer. The beginning of Soviet computing. The start of Soviet computing has been attributed to Sergei Alexeyevich Lebedev. As a student at Moscow Higher Technical School, MVTU, he studied electrical engineering. Afterwards, he became a teacher at MVTU and conducted research on power stations and power transmission at the V.I. Lenin All-Union Electrical Engineering Institute, VEI, and the Moscow Energy Institute. His work made him aware of the need for mechanical methods for solving mathematical problems. After World War II, in May 1946, Lebedev became the director of the Institute of Energy of the Ukrainian Academy of Sciences in Kiev. There, he promoted the concept of digital computers to satisfy the demand for computation for research. By the middle of 1947, the concept of MESM, Malaya Elektronная Счетная Machina, or Small Electronic Calculating Machine, was being created and being refined. In Lebedev's endeavors in recruitment and acquisition of resources for his electronic computing project, one of his major problems included a general lack of knowledge about computing. In hiring people for his project, very few understood what he was doing, and most knew not its significance. The fact that few knew the significance of his work also meant that it was more difficult for him to receive funding and materials from the government. As a result, Lebedev often needed to introduce such fundamental concepts as binary operations to all newcomers and those who were curious about his project. He and his team also produced a documentary script and submitted it to several places in an effort to increase his visibility, but the documentary was never made. One key detail, which serves to help in illustrating the lack of consideration being given to Lebedev's electric computer project, is the fact that he was allocated a badly damaged former monastery as a place to build his computer, and only after appeals on his behalf by Mikhail Alexeyevich Lavrentiev, who was the vice president of the Ukrainian Academy of Sciences. This monastery was 15 kilometers on unpaved roads from Kiev in Feofania, which made transport of materials and people difficult. There was also neither heating nor cooling except for air blown by fans. After much hardship and labor, BESM was ready for its first test in November 1950. They asked BESM to multiply 2 times 2, and BESM answered in a non-avant-garde manner. For the rest of the year, improvements were made. On 5 January 1951, BESM was recognized as a success. It was, however, not meant to be a computer to be used for serious calculation, only a prototype to verify the principles of electronic computing. However, improvements continued so that it would become useful in scientific computing. Meanwhile, Lebedev began designing his next machine, the BESM. The conflict between BESM and Strela. At this point, the importance of machinery in the performance of calculations was beginning to be known. This did not mean, however, that Lebedev would have much less difficulty in the near future. Besides Lebedev and his organization, the Institute of Precision Mechanics and Computer Technology, ITMVT, he also faced rivalry from Yuri Yakovlevich Basilevsky and his organization Special Design Bureau No. 245, SKB 245, which was part of the Ministry of Machine and Instrument Construction, MMP. While Lebedev developed the BESM, Basilevsky developed the Strela. With 2 competing projects and limited industrial capacity, conflict was nearly inevitable. Both the BESM and the Strela required cathode ray tubes in their designs. Lebedev saw that CRTs might have been in short supply, so he had a plan to circumvent this problem temporarily. Though the BESM was brought to a working state, it fell short of its designated speed. Meanwhile, the MMP had closer ties and greater political power. It took advantage of its position to monopolize the supply of CRTs, leaving the BESM in perpetual short supply. This caused Strela to seem superior since it was faster than the crippled BESM. Basilevsky demonstrated the superiority of his machine and was recognized as a hero of socialist labor, while the Strela was put into serial production. The early political success of the Strela, however, was short-lived. The machine was said to be very unreliable, since most of its parts needed to be replaced after only 1 year. Besides that, it was unable to solve the very questions for which it was designed to solve. Lavrentiev convinced the Soviet Academy of Sciences to compare the Strela to the BESM, where it was concluded that the BESM was superior. Lebedev was recognized as a hero of socialist labor while production of the Strela ceased, after only 7 units had been produced. The BESM was applied to such subjects as astronomy, chess, and language translation. Were they copies of Western computers? During the time when Lebedev was creating the BESM, there were questions as to whether he arrived at its design independently of the West. There were similar experiments in digital computing, such as the ENIAC and EDVAC, the designs of which Lebedev could have learned of and reproduced in BESM and the computers that came after. The concept of the stored program computer, for which John von Neumann has been credited, was also used in BESM. While it might have been possible for Lebedev to copy the designs of ENIAC among other machines, there were several reasons that made this unlikely. Detailed literature about foreign machines was difficult to obtain. During a conference in 1951, he stated, "I have data on about 18 machines created by Americans, but this information is primarily advertisement, without any notion about the way they were built." Details about the computers being made in the US and the UK also were not prioritized by the KGB, since the applications of computers were not widely known, even by the Soviet government at that time. There was also ideological opposition to adopting Western ideas, as exemplified by the fact that Soviet originality needed to be proven. The stored program concept in the West was considered groundbreaking and fundamental and is still used in the design of computers today. By storing the program in memory, it was possible to reduce the number of components needed to construct a computer that used this concept. Such a computer was said to use the von Neumann architecture, after he had expressed it in his A First Draft of a Report on the EDVAC. In the building of the BESM, Lebedev used the stored program concept. It may have been that it was a rather obvious and self-evident idea, likened by Hermann Goldstein, one of those involved with the ENIAC, to the invention of the wheel. Konrad Zuse, who produced computers for Germany during World War II, had also arrived at the stored program concept independently of von Neumann. In its early days, Soviet computing was original and not strongly influenced by Western ideas. Over time, this came to change. In the course of Soviet computer development, hardware designs which were compatible with, and sometimes clones of, Western computers came in the late 1960s. ES, the Elbrus, and Soviet personal computers. During the 1950s and 1960s, the Soviets made many advances in computer technologies. Lebedev went on to create many other computers until his replacement in 1973. The most notable of these was the BESM 6, which was not based on vacuum tubes, but transistors. Over 350 units of the BESM 6 were produced, and it was the most widely used machine in the Soviet Union. Its manufacture continued until about 1980. There were also other significant computers, such as the Saturn, which was a ternary computer, and the Ural. In the 1970s, the Soviet Union had a wide range of different computers, among which the differences in architecture and structure made their software incompatible. One series of compatible computers was ES, Единая система, or Unified System, which was based on the IBM 360/370. This series of computers was designed for compatibility of peripherals and software among all its models. This allowed software and hardware to be reused, saving time and money on software development and manufacturing. A series of small computers, SM, was also compatible with various Western computers such as the PDP-11, HP 2116, and the VAX-11. The Elbrus was a machine which was strongly influenced by the designs of the Burroughs 500 and 700. The design seemed so similar to the Soviet engineers that they sometimes called it the Elbrus. This did not mean that the Elbrus was a direct clone, however. The details which they learned about the Burroughs machines were used to address the weaknesses in the Elbrus's design. The Soviet Union did produce personal computers, but they were never produced in such volumes as their equivalents in the US. Many of them were compatible with Western computers. The Agat series, for example, was compatible with the Apple II and was used for educational purposes. The Hobbit was a clone of the Sinclair Spectrum. There were also many computers which stood on their own, such as the Electronica BK series and the Micro 80. Comparison with the West. Throughout the Cold War period, the Soviet Union lagged behind the West in terms of computer technology. A few reasons for this included political wrangling and limited resources, as demonstrated by the conflict between the designers of the BESM and Strela. It is possible that, without the intervention of Lavrentiev on behalf of Lebedev and the BESM, the Soviet Union would have fallen even further behind. While the BESM-Strela conflict took place, Remington Rand's UNIVAC was used to predict the 1952 election in the US, creating great publicity for the concept of computers. The completion of the UNIVAC spurred IBM to take its leap into the civilian computer market. This allowed it the resources to develop its technology further, eventually allowing it to dominate the market. In the 1970s, the US saw the beginnings of Microsoft and Apple Computer. These two companies were able to thrive in the market economy of the US. Microsoft sold the BASIC programming language while Apple sold computers. Both of these, and many other computer-related companies in the US, have grown to be major players in the world economy today. In contrast, the Soviet Union did not adopt computers as a part of daily life as readily. In an article by Time, Soviet Union Computer Games from 1975, it was stated that the US had over 300,000 computers, while the Soviet Union had an estimated 22,000. It also stated that many Soviet organizations had not incorporated computers into their operations, and that an average Soviet citizen rarely ever saw one. Industrial production of parts in the Soviet Union also fell short of that of the US. This deficiency was not only in terms of quantity, but also quality. This was due to their method of production and distribution, which excluded market forces, opting for distribution by decree, which often delivered outdated equipment too late. These problems continued even until perestroika, which actually worsened the problem. Conclusion. Russia was a latecomer to the world of computers for various reasons. The Soviet Union had its own computer culture, largely independent of that of the West. Many of their machines were built largely independently of Western influences until the late 1960s. Although they had trouble with internal conflicts and unstable parts, they were still able to produce computers that were on par with their Western equivalents early on. Unfortunately, the excess bureaucracy and lack of market forces put them perpetually behind the developments in the US. Today, the world computer market is dominated by such recognizable companies as IBM, Microsoft, and Apple. These companies sell hardware and software worldwide, including Russia. Although the Soviet Union was unable to stay ahead of the United States in terms of hardware, the present-day Russian Federation does have an advantage in terms of computer science education. Russia is currently attempting to stimulate innovation by replicating the conditions which resulted in companies such as Apple. If companies can rise so precipitously in Russia as they had been in the US, we may one day buy our computers and software from Yabloko.